Sub question number 7. Left hand side, sine theta minus 2 sine cube theta divided by 2 cos cube theta minus cos theta. And right hand side, you'll have to get here tan theta. So now, first step, since here sine has power 3 and here only 1, so we can't take here the identities. Likewise here, cos cube, here only cos 1, so we can't take here the algebraic formula. So in that case here, what you'll have to do, take sine theta common. So taking here sine theta common. So after taking here sine theta common, then sine theta into 1 equals to sine theta minus here 2. So sine cube theta. So since we have taken here sine theta common, so only we left with sine square theta divided by, even here deno plus, we can take here a cos theta common. After that here 2 into cos cube change to now square theta minus here cos theta into 1 equals to cos theta. So which is equals to, now sine theta by cos theta is the reciprocal of tan theta. So now we can take here tan theta. After that here you'll have to cancel these two parts. So we need to convert into same factor. Either convert sine square theta into cos square theta, if not cos into sine. So here 1 minus 2 into sine square theta divided by. So here we have 2. After that here, take the identities. We know that here, which is equals to cos square theta is equals to 1 minus sine square theta. So now taking here the fundamental identities, we know that here cos square theta is equals to 1 minus, that is sine square theta, we can close. After that again here minus 1. Now after that here what you'll have to do, so numerator plus, you'll have to drop the same terms here, tan theta within bracket 2 minus, here it is only 1, so 1 minus 2 into sine square theta divided by deno plus. With this 2 you can multiply both the terms, so 2 into 1 equals to 2 minus 2 into sine square theta equal to 2 sine square theta minus, we have here 1. After that here numerator plus, we need to drop the same here, tan theta within the bracket 1 minus 2 into sine square theta divided by, now we can collect the like terms, 2 minus 1 equals to 1. After that here we left with minus 2 into sine square theta. Now since here if you compare these two factors are now same, so we can cancel these two parts. So we left with tan theta, and that is also equals to our right hand side. Question number 9. LHS cosec A minus sine A into secant A minus cos A. Here, according to the questions here, you'll have to prove LHS and RHS separately. We need to solve. So let's have a look first the left hand side. So now here, since all the given terms are without square, one must have to convert the given terms into sine theta or cos theta. So now at that time we take the reciprocal. So the reciprocal of cosecant theta is equals to, yes, that is 1 by sine theta minus sine, you'll have to keep the same here. Similarly, secant theta, the reciprocal of secant theta is equals to 1 by, which is equals to cos theta minus the cos, we need to keep the same here. After that here within the bracket, since we have got here fractions, you'll have to take here the LCM. The LCM of sine A and 1 is equals to sine A. So now sine we can cancel, so numerator 1 minus, here it takes a cross multiplications, sine A into sine A equals to sine square A. Similarly, again here take the LCM of cos A and 1 will be cos A. So here take a cross, so we get 1. Similarly here minus cos A into cos A equals to cos square A. Now we got back with a square, which means we can take the identities. So here we know that 1 minus sine square a equals to, yes, that is cos square a divided by sine a into, again here with square, which means we can take the identities. 1 minus cos square a equals to, yes, that is sine square a divided by the next one we have here cos a. So now here we can cancel sine a, sine a. So sine a, here we can cancel the power. Similarly, cos a got the power. So we left with, which is equals to cos a into sine a. That will be our LHS part. Now let's have a look to the RHS part. So now the RHS part here, we have 1 divided by, that is 10a plus, which is equals to, we have here cot a. So all these are without a square, which means we can take the reciprocal. So numerator, we drop the same here, 1 divided by tan theta reciprocal. We know that tan theta is equals to, yes, that is sine a upon, which is equals to cos a plus, again here cot. That means reciprocal will be cos a divided by sine a. So after that, what we do? Yes, that is, you'll have to take the LCM at denominator plus numerator. You'll have to drop the same value here, which is we have 1. So the LCM of cos a and sine a will be, yes, which is equals to cos a and sine a. Now it will take a cross multiplication. Sine a into sine a equals to sine square a. The main sign we have here plus cos a into cos a equals to cos square a. So now we have here numerator, like we did on the previous step, drop the same here. But denominator, if you observe properly, the given terms has square, which means we can take the identities. We know that here sine square a plus cos square a equals to, yes, that is 1. So divided by, again we have here, which is cos a into sine a. So now here you'll have to do the necessary arrangement. That is equals to numerator, we can drop the same here. The division takes here multiplications. At that time this takes a reciprocal. So which is equals to cos a into sine a divided by 1. So we can cancel, that is equals to here 1 we can cancel. So we left with cos a into sine a. So here we have got, now we can say that here left hand side is also equals to right hand side. So hence verified. Sub question number 8. Sine a plus cosec a the whole square plus cos a plus sec a the whole square. So now to prove here LHS equals to RHS, take the help of the identities. Right now we can see here a plus b the whole square, and that can be expanded to a square plus b square plus 2ab. Now both the given factor we can expand into a plus b the whole square. So now taking the help of here the identities, so a, which means sine, b means cosec. So now take the help of identities. So a plus b the whole square equals to, that is a square, which means sine square theta, plus b square, which is equals to cosec square a, plus after that here 2 into a, which means here sine a into b, which is equals to cosec a. After that the main sign we have here plus, again here a plus b the whole square. So that is also equals to a square plus b square, which is equals to sec square a plus 2 into a into b. So 2 into, which is cos a into sec a. Now which is equals to, now sine and cos, these two you can group together, it has a relation. So within the bracket we group together sine square a plus after that cos square a, after that plus, now cosecant square A, since it has a square, take the help of the identities. So we know that here cosec square A equals to 1 plus cot square A, plus after that we have here 2 into sine, you'll have to drop the same here, sine A into, now cosec without square, which means you'll have to change this into sine, if not cos. So take the reciprocal of cosec. The reciprocal of cosec is 1 by sine. So 1 by sine A. So sine we can cancel. After that here plus cosecant square A, that is cos square A I've already taken. After that we left with a sec square A. Since it has a square, you can take the identities. We know that here sec square A is equals to 1 plus, that is a tan square A, plus again we have here 2 into, that is a cos A into. Now the given term sec, you'll have to change it into sine, if not cos. So the reciprocal of sec is 1 by, which is cos theta. So cos A we can cancel. Now we can see here, that is sine square theta plus cos square theta equals to, by using the identities we get here 1. After that here plus again we have here 1, plus again we get here cot square A, plus 2 1 is 2, plus again here 1, plus again we have here, that is tan square A, plus 2 1 is 2. Now we can collect all the constant value, 1 2 plus 2 4 5 6 7, so 7. After that take first 10, because at right hand side we are getting tan square A first, followed by the cot square A, and this is also equals to the right hand side.